In this video, I'll look at another application of quadratic functions, one we've seen before related to projectiles. This one's a little bit different though. A ball is projected upward from ground level at an initial velocity of 64 feet per second. What is the maximum height the ball reaches? And we also want to find when will the ball reach the ground. This one's different because it doesn't give us the actual quadratic function. We have to create that. But we're going to use the fact that the height of a projectile can be modeled by S of t, which is equal to negative 16t squared plus v sub 0t plus s sub 0, where t is time in seconds, v sub 0 is initial velocity in feet per second, and s sub 0 is initial height in feet. So we have the information that we need to get this quadratic function. S of t is equal to negative 16t squared plus v sub 0 is our initial velocity, and we're actually told that the initial velocity is 64 feet per second. So we're going to put 64 in for v sub 0, and that's times t, plus s sub 0. S sub 0 is the initial height. So the ball is actually on the ground. The initial height is 0 feet above the ground, so it's actually just 0. If you were told a specific number there, then you would put that into the function. So this is our quadratic function that represents the height of this ball. And to find the maximum height, think about the type of function we're given. This is a quadratic function. The value of a is negative, which means that the graph is a parabola that opens down. So the maximum height is reached at the vertex of this function. So to find the vertex, we want to find t is equal to negative b divided by 2a, or in this case, negative 64 divided by 2 times a, which is negative 16. So this is negative 64 divided by negative 32, which is 2. Now 2 represents the seconds. To find the actual height, we need to substitute 2 into our function. So s of 2 is equal to negative 16 times 2 squared plus 64 times 2. Simplifying, exponents first, this is really negative 16 times 4 plus 128, or negative 64 plus 128, which adds to 64. S is the height of the ball in feet, and because this is the vertex, the maximum height that the ball reaches is 64 feet. It reaches it 2 seconds after it was projected up. The second part of this says, when will the ball reach the ground? So the height on the ground is 0 feet. So when will the ball reach the ground? We're going to set our function equal to 0. So now we have a quadratic equation that we need to solve. We can solve this one by factoring. There's a common factor of negative 16t. And if we take out negative 16t, we're left with t minus 4 is equal to 0. So setting these factors equal to 0, we get negative 16t equals 0, or t minus 4 is equal to 0. Divided by negative 16, we get t is equal to 0. Or adding 4, we get t is equal to 4. So 0, remember these are seconds, 0 seconds and 4 seconds. So 0 seconds was the initial height, right? Initially it was at 0 feet. Then it went up to this maximum height of 64 feet after 2 seconds. And then in 4 seconds, it came back down to the ground. So when will the ball reach the ground? It will reach the ground 4 seconds after being launched.